Hello, welcome to Prajim Technologies. I'm Venkat. This is part 55 of SQL Server. In this session, we'll learn about handling errors in SQL Server 2000. In the next session, we'll talk about how to handle errors in SQL Server 2005 and later versions. Before continuing with this session, I strongly recommend to watch part 18 of this video series where we have covered the basics of stored procedures. With the introduction of try-catch blocks in SQL Server 2005, error handling in SQL Server is similar to programming languages like C# and Java. In SQL Server 2000, to handle errors, we use a system function @error, whereas in SQL Server 2005 and later versions, we can make use of try-catch blocks, which we will talk about in the next session. Sometimes these system functions that begin with @sign are called as global variables. Remember, they are not variables and do not have the same behavior as variables. Instead, they are very similar to functions and should be referred to as functions rather than variables. In this session, we'll be working with these two tables, TBL product and TBL product sales tables. TBL product table is like the inventory table, which holds information about the products that we sell, their unit price, and the quantity available. Product ID is the primary key. And this TBL product sales table is the table which contains the transactions that we made. For example, if I sell a product, then it holds information about what product did we sell, which is nothing but product ID, and what is the quantity, which is quantity sold. And product sales ID is the primary key for this table. So obviously, when we sell a product, there are two things that needs to happen. First, it needs to check the product that we are trying to sell. Do we have enough quantity available? Once we determine that, we need to deduct the quantity that we are trying to sell from the quantity available. And then the next step is to insert a row into this TBL product sales table. For example, if we are selling laptops, product ID laptops is 1, so 1. And how many we want to sell? Let's say 10, for example. 10 is the quantity sold. So obviously, when we sell a product, there are two things that's happening. One is updating this table, updating the quantity available for the product that you are selling. And the second step is to insert a new row into this table, TBL product sales. Let's look at a stored procedure that is capable of selling products. Now, if you look at this stored procedure, it seems to be very big, but trust me, it's very simple to understand. All this procedure does is update this TBL product table, the quantity available column, and insert a new row into this table with some processing steps in between. Let's look at this. Now, this is the stored procedure, which is basically selling products. Obviously, if a stored procedure has to sell products, it has to have two parameters: the product that we want to sell, the product ID that we want to sell, and the quantity that we want to sell, both of them of type integer. And if you look at this, the first thing the stored procedure is doing, check the stock available for the product that we want to sell. Now let us say, for example, I want to sell laptops 10. If you look at the product ID is 1, 1 is nothing but laptops. And what's the quantity that we want to sell? We want to sell 10 of them. So the first thing, when we want to sell 10 laptops, the first thing to do is to check, do we have enough laptops in the stock? And to do that, we are declaring a variable of type integer, stock available. And into that variable, we are selecting the quantity available from TBL product, where product ID is equal to 1. 1 is nothing but laptops. So this variable will now contain the stock available for laptops, which in this case is 90. So stock available will contain 90 now, and the amount that we want to sell is 10. So if stock available is less than the quantity that we want to sell, stock available is 90, the quantity that we want to sell is 10. 90 less than 10, false, so it doesn't come into this block. But on the other hand, let us say I want to sell 100 laptops, but then what is the quantity available? Only 90 is the quantity available. So what happens? It comes into this if block, and it is throwing an error here, not enough stock available. And to throw that error, we are using this function called raise error. In C Sharp, we use throw keyword to throw an exception, whereas in SQL Server, if you want to throw a custom error, then we use this raise error function. And if you look at the raise error function itself, it has got three parameters. The error message that we want to return back, okay, which in our case is not enough stock available. And then there are another two parameters, error severity level and error state. Now the severity level in most cases is 16, and 16 indicates general errors that can be corrected by the user. Okay, so most of the time, if you want to return custom errors, the severity level is 16, which indicates that these are the errors which can be corrected by user. For example, how do we correct this error? Now we know that the stock available is 90, so obviously we cannot sell 100 laptops. So just by reducing that to 80 probably will fix my error. Okay, so severity level is 16 here, and the other parameter is the state. Now error state is a number between 1 and 255, but raise error, when we use raise error to throw a custom exception, custom error, the error state can only be a value between 1 and 127, but in general we use 1. So the error state is 1 here. So this will throw an exception if the stock available is less than the quantity that we want to sell. On the other hand, if it's not, then it comes to the else part. So we have determined when we are in this else part, we know that okay, there is stock available. So if there is enough stock available, what we need to do, we need to first update this TBL product table, the quantity. Now let's say I want to sell only 10 laptops. Okay, so let's say 10 is the quantity that I want to sell. Product ID is 1, which is laptops. So we are in the else box. The first thing that we have to do is update that product table, quantity available column. So quantity available is equal to quantity available minus the quantity that we want to sell. In this case, we want to sell 10 laptops. So what happens? From 90, we are subtracting 10 and updating this quantity available column for laptops row. So that's what this update does. And then the next thing is, after we update this TBL product table, we need to insert a new row into this table. Now to insert a new row into TBL product sales table, you need values for 3 columns. Okay, product sales ID, obviously that's the primary key, so you will have to supply that. The product ID and quantity sold. The product ID and quantity sold are coming in as parameters to this procedure. So we have those product ID and quantity sold, 1 and 10. But the third thing is the primary key itself. We need to calculate the primary key for this table that we need to insert. Now already if you look at the key values, we have 1 and 2. So we need to calculate the next primary key, which is 3. And to do that, all we are doing is we are using an aggregate function max, which returns the product, the max of the product sales ID. And then look at this. What we are doing here basically is, if there are no rows, let's say for example this table is empty, we are making our first transaction, for example. Okay, when this table is empty, when you say select max of product sales ID, that will be null. So when that is null, your max product sales ID will also be null. When it is null, instead of storing null in this, we are storing 0. Else whatever is the value. And the reason why we are doing this is because look at the next step. What we are doing, we are actually incrementing that by 1. So if there are rows, okay, 1 and 2, there are 2 rows here, what happens? It checks here, it uses this case statement. When max of product sales ID is null, no, it's not null. If it is not null, then it comes here, max of product sales ID is 2. So our max of product sales ID contains 2, and then we are incrementing that by 1, so it will become 3 here, and the product ID is 1, quantity to sell is 10. But on the other hand, let's say when there are no rows in this table, in that case what happens? Max of product sales ID will be null. If that is null, then we are storing 0 in this max product sales ID. So 0 plus 1 is 1, so the first row will have a 1 of 1 for this column. So that's why we are using this case statement. and then finally what we are doing, we are inserting into this table. It's pretty simple. All you are doing, I mean, there are three steps here. First, check the stock available. If the stock available is less than the quantity that we want to sell, throw an exception. Otherwise, update the product table with the quantity that we are selling, and then compute the next primary key that we want to insert into TBL product sales table and insert a row into that table. That's about it. Okay, so let's create the store procedure now. So command completed successfully. The stored procedure is now created. Let's see what we have in these two tables now. So if you look at this, the quantity available, there are 100 laptops and there are 50 desktops. Laptops product ID is 1, desktops product ID is 2. Now let us say I want to sell, product with ID is equal to 1, 10 is the quantity. So when we press this, what should happen? This quantity available for laptops should become 90, and there should be a new row into this table, TBL product sales table. So execute that. So command completed successfully. Execute this. Look at that. Very good. So 10 decreased from the quantity available. There is a new row here in TBL product sales with product ID is equal to 1, quantity sold is equal to 10, which is as expected. Now let's try to introduce some error into the store procedure. Now intentionally I am getting rid of this line. I'm actually commenting this line. So when we comment this line, look at what's going to happen. It gets the maximum of product sales ID, and then it tries to insert the same product sales ID, which is the primary key in TBL product sales table. So obviously we will get a primary key violation. So at the moment, if you look at the rows that we have in TBL product and TBL product sales tables, the product sales ID is 1, and what happens when we try to insert another row with the same ID? We get a primary key violation error. And let's see what's going to happen now. So let's alter this store procedure. Okay, so now let's try to sell 10 laptops again. Now remember what happens when we try to execute this store procedure. It updates the table, in the sense it reduces the inventory from 90 to 80, but then it will not insert a new row into this table. Let's see that. So if you look at the available stock now, look at this. What's the available stock for laptops? 90. Okay, now when we sell 10 laptops, now what should happen? There should be another row with product ID 1 and quantity sold 10, and then this 90 should become 80. But then remember, we have intentionally introduced an error here. We are not calculating the product, the next primary key value, because of which we get a primary key violation, which means this statement will be successful and this statement will not be successful. And this is inside a transaction. So what happens? This changes will be made and this changes will not be made. So these statements are no longer being treated as a transaction. So our data is now going to become inconsistent, because one statement succeeded and the other statement failed, but still those changes are retained. Okay, so let's see what happens first. Execute. Look at this. One row affected, and then there is a violation of primary key constraint and the statement has been terminated. And if you look at this, the product, the quantity available, see, you have reduced the quantity available, but you haven't recorded a sales transaction, which means your update didn't work as expected. Okay, so this update and insert should be treated as a single transaction. Either both of them should succeed or none of them should work. If one of them fails, the other statement should also be rolled back. Okay, and why were we not able to properly do this transaction? Because we didn't check for errors. So in SQL Server, how can we check for errors? As I told you, we use this system function @error. Let us see how to use that @error system function, and then roll back the transaction if there are errors, and if there are no errors, then we will commit the transaction. But then if you look at the way the stored procedure is written now, it's committing the transaction without even checking for any errors. Okay, so it's saying update this, calculate the max product sales ID, and then insert the row and finally commit the transaction. Okay, but then we'll have to check, okay, when I executed this, did we encounter any errors? When I executed this, did I encounter any errors? When I executed this, did I encounter any errors? When there are, when there is an error whenever you execute either this statement or this statement, then you will have to roll back the entire transaction. If there are no errors, then we commit the transaction. So let us see how to do that using this at error system function. So to do that, what we are basically going to do is I'm going to check if at error is not equal to 0. So basically this system function will contain a non-zero if there is an error. If there is no error, if the statement has successfully executed, then it will contain 0. So if at error is not equal to 0, then that means there was some error. Okay, and remember, if there is an error, we want to roll back this entire transactions. Again, we haven't spoken about transactions yet. We'll be talking about transactions in a great detail in the later sessions of this video series. So if there are errors, we want to say rollback transaction. You can either use the complete word or you can just say rollback tran, just like how we have done here, begin tran, commit tran. On the other hand, if it's equal to 0, then we know there are no errors and we can commit the transaction. So all I'm doing is a simple modification to this. And look at this one. This line is still commented, which means we are going to get that primary key violation. But then since we are checking here for the error condition, and then if there are errors, we are saying roll back the transaction. Okay, so let's alter this procedure once again. So now let's go ahead and try to sell 10 of laptops again. Now before we execute that, let's look at the state of the database. So laptops quantity available is 10 and we are trying to sell 10 of them. So what should happen? They should become 70 and a row should be inserted here. But we know when it tries to insert a row into TBL product sales table, we'll get an error. When that happens, we need to even roll back the update that was done to TBL product table. Let's see if that happens. And just so that we know whether if a statement is committed or rolled back, what we will do is we will wrap this inside a begin and end statement. And then we'll also print a message saying that transaction rolled back. So transaction rolled back. And along the same lines, we'll wrap this inside a begin and end. And we'll say transaction committed. So let's alter this. So now let's try to execute the store procedure. Press F5. Look at this. The statement has been terminated, and if you look at the message, transaction rolled back, which means we know that this particular piece of code got executed. Transaction rolled back, which means it has undone the update as well. So obviously if you check, the quantity available should still be 80. But on the other hand, if we try to uncomment this line, which removes that error condition there, and now what happens, it will be able to successfully execute this insert into statement and will be able to commit the transaction. So let's say command completed successfully. Now look at the quantity available 80, and when we sell 10 laptops, what should happen? This 80 should become 70 and a new row should be inserted into TBL product sales table. So press F5, transaction committed, which means it has committed the transaction. And if you look at this, there is a new row here and the quantity available is 70. So to check errors, we are basically using this system function at error. But there is a slight thing that you have to keep in mind when you use this at error function, because look at this. This at error returns a non-zero value if there is an error, otherwise 0, indicating that the previous SQL statement encountered no errors. Now, keep in mind this at error is cleared and reset on each statement execution. Now, if you have to get the exact value, then you have to check it immediately following the statement that's being verified, or you have to save it to a local variable that can be checked at a later point of time. Let's understand what we mean by this with an example. Now, if you look at the example here, look at this. Let's say TBL product table. If you take TBL product table here, now we already have a row with ID is equal to 2, and product ID is the primary key. So obviously when we try to insert into that table another product with the same primary key, what we will get an error, primary key violation error. And then here you are checking, see, look at this, when we execute this insert statement, we get an error, and immediately after that statement execution, we are checking the value of this system function at error. If not equal to 0, then print error occurred, otherwise no errors. Now, since we are checking this system function immediately after the statement that caused the error, then it retains the error and it shows error occurred. Let's see that. Okay, so it's the same thing here. So let's copy this. So obviously when we try to execute this, we will get a primary key violation. When we execute that, look at that, error occurred. So it got in here. But on the other hand, let's look at this statement. So what we are doing here, we are inserting into this table the same query. So obviously we will get a primary key violation error here. But then I'm not checking the value within that system function immediately after that statement execution. After that, after I execute this statement, I have another statement here, select star from TBL product. So now this statement gets successfully executed. When this statement is successfully executed, what happens is the value that is contained in this at error is now reset to 0 because this select statement successfully executed. So at this point, if you check if at error not equal to 0, it will say it will be equal to 0. Why? Because this statement successfully executed. So the value is reset. So obviously now when I run this code, it will say no errors, and that doesn't make sense, right? So that's why anytime you use this at error, you will have to check the value of that immediately. Look at this. At error is cleared and reset on each statement execution. Check it immediately following the statement that's being verified, or the other option is save it to a local variable that can be checked at a later point of time. So that's what is this one. So we are declaring a variable of type integer at error. This is a local variable. And then when you insert, when you execute that insert statement, which is going to throw that primary key violation error, and then immediately after that, you are storing the value that's present in at error into this local variable. And then you are executing select star from TBL product, which will only reset this global variable, this global system function. But then this local variable contains the value that was, returned by this at error when this statement, when this insert into statement was executed. So at this point of time, you will get what you expect. So here we are saving the value to a local variable at error. So obviously now when we execute this, it's the same code that we have seen. It should print that message saying error occurred. So error occurred. Alright, in the next session we'll see how to use try catch to handle errors in SQL Server 2005 and 2008. On this slide you can find resources for ASP.NET C# and SQL Server interview questions. That's it for today. Thank you for listening. Have a great day.